A band brake acts on a 3/4 portion of the circumference of a drum having 450 mm diameter, which is keyed to the shaft. The band brake provides a braking torque of 2 to 5 Newton meter. One end of the band is attached to fulcrum pin of the lever and the other end to a pin located at 100 mm from the fulcrum. If the operating force is applied at 500 mm from fulcrum and coefficient of friction is 0.25, find the operating force when drum rotates in anti-clockwise direction and when drum rotates in clockwise direction. Given, first write down given a band brake acts on, so I draw here diagram first. Band brake, simple band brake. So one end is at 100 mm means 0.1 meter and another end is at 0.5 meter from the fulcrum, and I take force P as upward. 3/4 portion means 270 degree. 3/4 portion means 270 degree theta, and the radius of drum, diameter of drum is 450 mm. So here mu is equal to given 0.25, P is given, P is not given, P we have to find. We are going to determine P here. So braking torque is given TB 225 Newton meter. Now theta is 3/4 of circumference, means 3/4 of 360. So it becomes 270 degree. So in radian, 270 into pi by 180. In radian it becomes 4.7123 radian. Now, so this much is given. Now we are going to find out the value of P, that is effort required. So formulas, which formulas required? Formula required. Formula. So braking torque is equal to T1 minus T2 into radius of brake drum R. Then tension ratio T1 divided by T2 is equal to E raised to mu theta, and moment at O is equal to 0. This is O. So moment at O is equal to 0. So let us see how to solve this problem. So first condition take, drum rotates, if drum rotates anti-clockwise. If anti-clockwise rotation is there, if this is anti-clockwise rotation, if anti-clockwise rotation is there, then this becomes tight side, this side becomes slack side. So T1 is here, T2 is here. So we have braking torque, we have this formula. From this formula we are going to find out another value of tension. So first use braking torque formula. TB is equal to T1 minus T2 into R. TB you know 225 is equal to T1 minus T2 into R 0.225. So drum diameter we know 450 mm. So radius is equal to 225 mm, that is equal to 0.225 meter. So T1 minus T2 is equal to, is going to divide 225. So T1 minus T2 is equal to 1000 Newton. This is first equation. Now tension ratio T1 divided by T2 is equal to E raised to mu theta. So T1 divided by T2 is equal to E raised to 0.25 into theta 4.7123. Again it becomes 3.2481. Now T1 is equal to 3.2481 T2. So this is second equation. Put this value of T1 in equation 1. So 3.2481 T2 minus T2 is equal to 1000. So 3.2481 T2 minus 1 T2, so 2.2481 T2 is equal to 1000. So T2 is equal to 1000 divided by 2.2481. So T2 is equal to 444.8169 Newton. This is the value of T2. Now this value of T2 put in equation 2. T1 is equal to 3.2481 into T2. So that is equal to 3.2481 into T2 44.8169. So T1 becomes 144.81 Newton. Now we have both the values of tension. Now for first condition, take a moment at O is equal to 0. For first condition, T2 into 0.1 is equal to P into 0.5 minus P into 0.5 is equal to 0. So T2 we know 444.8169 is equal to P into 0.5. So P is equal to 44 into 0.1. 444.8169 into 0.1 divided by 0.5. So P becomes, for this case, 88.9633 Newton. This much effort is required to operate this brake. Now second condition, if drum rotates clockwise, for clockwise rotation, this side becomes tight side, this side becomes slack side. So take a moment at O is equal to 0. These values are same for both the conditions. So T1 into 0.1 minus P into 0.5 is equal to 0. Now T1 144.81 into 0.1 is equal to P into 0.5. So P is equal to 144.81 into 0.1 divided by 0.5. So P becomes, for this condition, 288.96 Newton. This much effort is required to operate the brake.